Let's look at C here. If you were to describe this problem, folks, am I writing an equal sign? No, I'm just pointing at it and describing the form. If I were to describe this problem, what form does it have? The indeterminate form, 0 over 0. This one's a little bit different than the rest. I actually don't ask this question all that often, but you see it in my math labs for this section. What are we going to do here? We can't factor it as it is. Well, we could try multiplying by a conjugate.
You can just multiply out the x minus 1 squared and then subtract the 4 and then factor.
Folks, I like it. Folks, somebody didn't put the blanket in the laundry closet away correctly. They just wadded it up. How are you going to fix it? First you have to what? Unfold it, then you fold it back up, right? I think of factoring as folding something up. Okay? So if I were to describe that numerator, I'd say first we got to unfold it all the way out, and then hopefully we'll be able to factor it like we did the first problem. Okay? So the first thing I'm going to do here is I'm going to write the limit as x approaches 3 of, here I've got x squared minus 2x plus 1 minus 4 all over x minus 3. And that gives us the limit as x approaches 3 of x squared minus 2x minus 3 all over x minus 3. Now I feel like this looks maybe more like the problems we saw before. So now we'll try maybe that, what strategy do you think we should try now? Now we've unfolded the blanket up in the numerator. Let's try factoring and see if we can, because why? I still cannot do direct substitution on this problem. 0 is still not in the domain. Time out. Everyone look at your work. You may do this in fewer steps than me as far as algebraic simplification. When it comes to algebraic simplification, I'm fine with that because those are steps you learned in a previous class. But when I teach you a step in this class, you have to show it. Because when I go to grade your work, I'm going to say, did you learn how to do this step? And if you skip it, then I'm not quite sure whether you made by some misunderstanding you went from here to here and got the right answer, or you did the correct steps and got the right answer. Do you all agree that there are ways to get to the right answer the wrong way, right?
Yes.
So look at your work now and see, do you have the limit, the limit, the limit, the limit, the limit, until between here and here, what did I do? Right here, I applied the direct substitution property. So do you have the limit written before that every time? If not, I'll mark you partially wrong. I'm not going to beat you over the head with it, right? I'm not going to give you 0 out of 5 on a problem, but I'm going to mark you one point down for poor notation because, folks, in a foreign language class, if I ask you in a foreign language what color is the sky, and you answer blue in English, you gave the correct answer to the color of the sky, right? Did you show me you learned the language you were supposed to learn in the class?
No.
No. Your goal is to show me that you're learning the language of limits, right? All right. Let's look at this question here. Let me give you a second. I'm going to pause. Go ahead and give it a try. So folks, if I were to describe this, I would say that this has the indeterminate form 0 over 0. Does everyone agree?
Yes.
Just like all of the other problems we've looked at, with the exception of the one that started out as 0 over 0 and then became a over 0. Okay. What's our strategy here? Well, why don't I do direct substitution on this problem, folks?
Because you can't a 0 in the denominator.
Because of the x minus 3 factor in the denominator. So folks, I want you to get away from what steps am I supposed to do and change your thoughts to like what options do I have to get to where I want to go. My general strategy is to try to cancel this factor, right? I would like to cancel the factor x minus 3. If I could cancel the factor x minus 3, then the thing that's preventing me from doing direct substitution would be gone. Do you all agree? Does that expression make sense when I say that? If I could if I could cancel that factor of x minus 3 in the denominator, then I could do direct substitution. Well, I'm going to have to cancel x minus 3 with something in the numerator, right? But what's the problem? I've got an x that shows up inside of a square root, right? And I've got a 3 that shows up inside of a square root. I'd somehow like to free those out. So now we'll ask the question, what should I do on this problem? Yeah, we're going to multiply by the conjugate of the square root expression to try to free something up. Okay? And so what's the conjugate of this square root expression? It's the square root of x, what? Plus the square root of 3. Is that all I need to do is multiply by that?
No, over, like divided by the square root of x.
Folks, is this the number 1 right here?
No.
Then I can't multiply it to this expression, right? You can only ever multiply an expression by 1 and not change it. So that's why we multiply it, as Cortica said, as the conjugate over itself is getting multiplied to it. Because now, what's this expression, the whole thing in green, what does that simplify to? 1. And I multiply by 1 in a clever way that's hopefully going to make my life easier. So folks, when I do this, now, if you're rusty on this step, Raymond and Christy have their SI session today. If you're rusty on this step in the numerator, practice it a few times, come to SI and talk to them about it. I foiled that out so many times that I know what's going to happen. When I multiply my firsts together, I'll get a perfect square. So I'll just get x. And I know from experience, when you multiply an expression by its conjugate, that the outers and inners will always cancel out. If you don't believe me, or even if you do, check me on that. Then I know when I multiply the lasts together, I'll get the square root of 3 times the square root of 3, so I'll get that expression squared, which is just 3, but I still have a minus sign, so I get x minus 3. Okay? All over x minus 3 times the square root of x plus the square root of 3. Now, don't say it out loud. What's your next step? I want to point something out to you. I've had a lot of students in the past FOIL this expression in the denominator. Is that allowed?
Yes.
Yes. But why have we gone down this road to begin with?
To cancel.
To cancel the factor of x minus 3, right? And if I start scattering its pieces around by FOILing, I won't be able to figure out how to cancel it. And in fact, instead, in this case, I doubt people would do that in this case, because it's very obvious that you can cancel here. But I've had students FOIL out the denominator, and then they don't have anything to cancel. Okay? So we get this. And now I'm left with the limit, as x approaches 3, of 1 over the square root of x plus the square root of 3. And look at the domain of this new problem. I'm allowed to plug in what numbers for x? Well, I can plug in 3, yeah, sure, but I can plug in a lot of others, like 4 or 5. What else can I plug in for x? What can I not plug in for x?
Negative number.
Any negative numbers. Well, our limiting value is what? 3. Can I do it?
Yes.
Yeah. So I get 1 over the square root of 3 plus the square root of 3, which I'll write as 1 over 2 square root of 3. I'm perfectly happy with leaving the answer there. Could you do some other simplifying of that? Yes. I'm happy with that. Okay. Folks, at this point you might be saying, how simplified should I make my answer? Can we say that that's the wrong question to be asking at this point?
Yes.
We've got way too much math to learn to spend hours talking about how simplified should an answer be. Let's worry about learning all the procedures first, and then we can get our ducks in a row as far as simplifying goes. Okay? By the way, I'll tell you this. if you ask my math lab to help you solve this problem, they'd get to here and then they'd keep going in the help me solve this. That doesn't mean that they wouldn't accept this answer right here. It's just they're going to keep going a little bit more to keep simplifying. Okay? Most of the time, if you've got the right answer in a different form than they have it, it will still take it. So I've had students then get confused because they look at help me solve this, my math lab simplifies it even further than I do, and then they say, well, I guess I had to have done it to get the right answer. And no, it's not. It still would have taken this answer, it just won't show you that as the correct answer, it will write it a different way.
Over square root of x plus 3 to the next step.
So in fact, this is why, this is another reason, besides being correct mathematics, that it's very good to use this limit notation all the way through. What did I stop writing from here to here? I stopped writing the limit as x is approaching 3, so it's implied that I did the direct substitution property there. Right? Because, remember we had that discussion about the domain. Was 3 in the domain of the original limit question, the original expression?
No.
I could not plug 3 into the original limit expression. Can I plug 3 in here? Yes. And for reasons we don't quite yet have the vocabulary yet, the direct substitution applies to this expression, and so we can go ahead and do so. Okay, I'll have you guys try E on your own.
Yeah, so it's going to be negative x, negative 9 plus 9, so it's going to be negative x over x, and x, the negative 1.
And then you got negative 1 over 3 plus the square.
Wait, that's great notation. Yeah, because you're showing a lot of the words, you're showing the steps, how
Plus
you,
three.
it's easy to, I don't know if easy is the right word, but I can follow,
What's this word?
going from there to there, showing that
So
step
then you
of the
can just
distributing,
direct
multiplying by the conjugate.
So if you
So it's
From
gonna
there you
be
simplify that.
Oh, so the
The next
Turns
substitution
into
product
x
comes
plus 9.
in, so you get rid of the limit, because then you can't, you
So
plug
we're
in
doing
your
for
zero
square
for
root,
x.
square root.
Okay.
Then you get your answer, that's great. Something else too,
Takes rid of
a lot of people are a fan of the 2 lines, this also works. I do this mainly because I'm not engineering. Box and answer.
Gotcha.
But no, that's the way, that is like exactly the Charles notation.
Gotcha.
So you don't even have the boxes because you got the 2 lines.
I know, I kind of like figure same thing. I get lost in my work.
Yeah.
I just thought that I go back to where the answer is. I don't like where I don't say it's
Yeah. Yeah, that's why I like to do it too, because I think the 2 lines is a much faster way to do it. But like the box works so much.
Wait, if I got it correctly.
Folks, the place where students, after you've learned the multiply by the conjugate problem, and after you've done a few times, after you've got the basic idea and you're feeling pretty comfortable with it, the place where students go wrong is this step right here. When you FOIL this out, 3 times 3 gives you 9. Outers and inners cancel, and you're left with minus the square root of x plus 9 times the square root of x plus 9, which gives you minus all of x plus 9. Do you see that if you didn't write those parentheses, you would not get the right answer? Everyone see that? And so you need those parentheses there. When you distribute them through, you end up with a minus x, which is where I got that minus 1 from.